Hi Method students, in this video we're going to have a look at a past exam question involving area under a curve. So let's have a read and then give it a go. This question says part of the graph of this function f, where f of x is equal to x squared, is shown below. So we've got a picture of our graph of x squared. Zoe finds the approximate area of the shaded region by drawing rectangles as shown in the second diagram, which is this one down here. So we've got the approximation of the area using rectangles and then the exact area shown on the first diagram. Zoe's approximation is p% more than the exact value of the area. The value of p is closest to. Okay, so we're going to have to work out here the exact value and the approximation. So let's do that first. Let's start with the exact value of the area. The exact area, well, we know that we can find that using an integral. So the exact area would be given by the integral. Now from the diagram, it's from 0 to 6. So our terminals will be 0 and 6 of the function x squared with respect to x. Now, up to you, that's probably easy enough to work out by hand, but this was a multiple choice question from an exam too, so you can just chuck it in your calculator and get the value from the CAS, which is the way I've done it, and I got an answer of 72 for the exact area. The approximate area, well, that's just going to be found by finding the area of each of these rectangles and adding it up. One thing to look at carefully in the diagram, and it's a little bit hard to see for the smaller rectangles, but you notice it towards the ones towards the right, is that the rectangles are, I guess the height of the rectangle, it's the top right corner of the rectangle that's touching the curve. Okay, so what that means is that each of these rectangles, in order to know their height or their y value, we're looking for the x value on the right hand side of the rectangle. So the sum of the rectangles will be, it'll be first rectangle obviously has a width of 1, and it's also got a height of 1 because when x equals 1, the function value is 1 squared. So f of 1 just equals 1 squared, which of course is 1. So the first rectangle is going to be 1 times 1. The second rectangle, well, that height comes from subbing in x equals 2. And for this function, we sub in x equals 2. We get y equals 4. I won't write these all out, but of course, when we sub in x equals 3, we're going to get 9. X equals 4, we're going to get 16 and so on. So we're just going to get the square numbers will be the heights of each rectangle. So our area, our approximate area is going to be 1 times 1 plus 1 times 4 plus 1 times 9 plus 1 times 16 and so on until we get to 6 squared, because that's our final rectangle. Our final rectangle's got a height of 6 units squared. And so summing all of those is going to give us our total area or our total approximate area, and adding those up carefully, we get 91. Now, of course, just as a quick note, it wasn't necessary to actually write, 1 times 4, 1 times 9, 1 times 16, but it's just a good reminder because in a lot of cases, the width of the rectangles will just be 1 unit, but it's not always the case. So don't assume that it'll always be a width of 1. In another question, maybe the width of each rectangle might have been a half and we'd have had to multiply by a half, and obviously that would change the numbers. So just be a little careful with that one. Anyway, okay, so we've got our exact area, 72 units, our approximate area, 91 units. Now the tricky bit is this whole approximation is p% more than the exact value of the area. So we essentially have to work out the percentage increase if we're going from the exact value to the approximate value. So what we might work out first, or what we could say is, so p equals the percentage increase, and we're kind of considering 72 as the starting value, and we're trying to say, well, what percentage have we increased that number by to get it to 91? So a couple of ways you could maybe work that out, but I would say let's work out what the increase was, which will be the difference between 91 and 72. Divide that by what we started with, which of course was 72. And if you multiply that by 100, you'll get it as a percentage. Okay, so it's going to be 19 divided by 72 times 100. So we've increased by 19. The starting amount was 72. 19 as a percentage of 72 is, again, chuck it into your calculator, 26.388 repeated. So when we look at, so that's our value for P. The question said, what's it closest to? Well, it's closest to 25%. Okay, so in this one, the correct option is D.